This video is about summation notation. It's often important to find the sum of the first n terms of a sequence. In other words, a sub 1 plus a sub 2 plus a sub 3 plus all the way up to a sub n. So you're just summing all of the terms in the sequence up to a certain point. We will write that using summation notation. So what we would do is we would say sigma. This symbol is the Greek letter, the capital letter sigma. Sigma of k equals 1 to n of a sub n. That would be the easiest way to write the summation notation of the first n terms of a sequence. So this symbol is an instruction to add up all of the terms. Sigma just means sum them up. S for sigma, S for sum. Add them all up. That's basically what that means. The integer k is called the index. That tells you where to start, and then the part at the top tells you where to end it. So, for example, if I have the sum from k equals 1 to 3 of k, that would just be 1 plus 2 plus 3, which would be 6. If I had the sum from k equals 1 to 5 of k squared, that would be 1 plus, then I would plug in 2. 2 squared is 4. Then I would plug in 3. That's 9. Then I would plug in 4, and I would get 16. Then I would plug in 5, and I would get 25. And that would be what I would do. So I'd have 41, 50 plus 5. I'd have 55. This would be the sum from k equals 1 to 5 of k squared. And you can do that for a variety of other things. So let's write out each sum. K equals 1 to 5, the sum from k equals 1 to 5 of k plus 2. I just plug in 1 and I get 3. I plug in 2, I get 4. I plug in 3, I get 5. Plug in 4, I get 6. And I plug in 5 and I get 7. So I have 25 would be the answer to this one. The sum from 0 to 4, negative 1 to the k over 3 to the k plus 1. So now I'm going to plug in 0 for k. Negative 1 to the 0 is 1. And 3 to the 0 plus 1 is 3. So 1/3. Now when I plug in 1, I get negative 1 in the numerator. And then I have 3 squared in the bottom. So it's minus 1/9. Plus, how do I know it's going to be a plus? Because if k equals 2, the numerator would be positive 1. It's negative 1 squared is plus over 3 to the 2 plus 1. So that's 1 over 27. And it's going to be minus because negative 1 to the third. And then 3 to the 3 plus 1 power is 81. Then plus 1 over 243. And I could actually find this sum, but all I'm asked to do is write it out. Sometimes what you'll notice is you'll see these negative 1 to the k terms. This is a way to alternate between positive and negative terms in a sequence. So if you see negative 1 to the k, that indicates that you're going to alternate between positive and negatives. Now, k equals 0 to n, 1 over k factorial. Don't worry, 0 factorial is 1. So if I plug in 0, I get 1. If I plug in 1, 1 factorial is 1. If I plug in 2, 2 factorial is 2 times 1, which is 2. If I plug in 3, 3 factorial is 3 times 2 times 1, which is 6. If I plug in 4, I get 4 times 3 times 2 times 1 in the denominator, which is 24. All of these are supposed to be fractions. Sorry, kind of forgot about that part. So I have 1 plus, I actually don't need the fractions in these first two. That's probably why I kind of forgot about it. So I have 1 plus 1 plus 1/2 plus 1/6 plus 1/24. And then what I'm going to notice is that this goes all the way to n. So I'm never going to actually get there. So I have to put plus dot dot dot, and then plus 1 over n factorial is my last term. So this is my answer where I'm writing everything out. Then you can also use your calculator to find the sum of finite sequences. It's finite if it has an ending, so it doesn't go to infinity. And so basically here are the 3 steps. Step number 1, math button. Step number 2, go down in the math button to 0, which is summation. And then step 3, type it in. So for example, k equals 1 to 10 of k plus 2 over 3, I would have 25. Also notice if I typed it all in, 3 over 3, 4 over 3, 5 over 3, 6 over 3, 7 over 3, 8 over 3, 9 over 3, and so on all the way until I got to 12 over 3, I would also get 25. So it's way easier to just use the summation notation. We're going to calculate with paper and pencil first, then we'll use the calculator. So sum from k equals 1 to 4 of 2k plus 1. So what I'm going to do is plug in 1, that's 3. If I plug in 2, that's 5. If I plug in 3, that's 7. If I plug in 4, that's 9. So I would get 24. K equals 1 to 7 of this one would be 1/3 plus 2 squared is 4, 4/3. 3 squared is 9, so 9/3 or 3. 16/3. 25/3. 36/3 is 12. And then 49/3. So I could add all of these things together, and it's going to take me a little while. 5/3 plus 49/3, that's 54. 54 plus 41. 54 plus 41 is 95/3. That's not nice. Plus 15. 15 is 45/3. So this ends up being 140/3. So let's confirm these with the calculator and hope that I'm right. So what I would do is I would hit the math button. I'd go to summation. And then you can use whatever letter you want. I'm going to use k because that's what we tend to do. So k equals 1 to 4 of 2k plus 1 gives me 24. That's good. That means that I actually did it right. So now let's do one more. So k equals, oops, I was supposed to type something in. K equals 1 to 7 of k squared over 3, 46 2/3, which I'm going to convert to a fraction. That is 140 over 3. That's good news. That means your math teacher can add. All right, let's express using summation notation. So if I have 1 plus 2 plus 3 plus 4 plus dot 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 all the way to 20, that would be the sum from k equals 1 to 20 of k. Notice it's just indexing all of the numbers from 1 to 20, and then I add them all up. Letter B, so this would be the sum from k equals something to 6. I'll talk about the something in a second. And it looks like I have that alternating term up here. And then I need a 3 on the bottom. So now what I'm going to do is I'm going to focus on what I actually want to start at. I want to start at 0 because I actually need 7 terms. 0, 1, 2, 3. And I have to make sure that the alternator is actually doing the right thing. So if I plug in 0, I get a positive. If I plug in 1, I get a negative. So if k is 0, k is 1, k is 2. It seems like everything's working out. Now this 3 also needs to be doing something. So it looks like I end up with 3 to certain powers. So I should do 3 to the k power. Because if k is 0, 3 to the 0 is 1. K is 1, 3 to the 1 is 3. 3 squared is 9. So this ends up working out. I could also write it, since both the numerator and denominator have the same power, I could write negative 1/3 to the k, and that would work out okay also. Now, is it all right if I write the sum from k equals 1 to 7 of negative 1/3 k minus 1? Or the sum from k equals 1 to 7 of negative 1 to the k minus 1 over 3 to the k minus 1. Yeah, this would actually do the exact same thing as what I wrote in red. It's usually easier to avoid doing a lot of k minus 1 and stuff, but it's okay. Either one would be fine. So now this one, this is a lot of work, it seems. So 3 plus 9 plus 15 plus all the way to 255. So the sum from k equals, let's say 1 until some number up here, what I need to do is I need to figure out what's actually happening. It looks like I'm adding 6. So I need 6k minus 3, let's say. Because if I plug in 1, I get 6 minus 3, which is 3. If I plug in 2, I get 12 minus 3, which is 9, and so on. And then I would have to figure out how many terms there are up here. And that's something that we learned in the arithmetic sequence video. And what we would do is we would take 6k minus 3 and set that equal to our last term, and then see what value of k would actually make that work. So 6k equals 258, and then when I divide by 6, I get k equals 43. So it's k equals 1 to 43 of 6k minus 3. Last problem. What I have is I want the sum from k equals 1 until 9, it looks like, of x minus 2 to the k over 5. And now what I have to notice is that my first term does not have a 5 in the denominator, and my second term does. So I need a k minus 1 in the denominator. So if I plug in k equals 2, then I end up with 5 as my denominator. If I plug in k equals 3, I end up with 5 squared, or 25, as my denominator. And so that kind of seems to be the pattern that's developing here.